Hey guys, and welcome back to my channel. I hope you're staying safe and coding every day. Today I will teach you yet another fundamental coding algorithm, MergeSort. MergeSort is a recursive algorithm that divides and conquers, much like quicksort. Check out that video in the description below if you haven't already. So let's say we have an array of integers, 3, 7, 2, and 8. MergeSort works by dividing down an array to multiple single index arrays. We then take each item, compare them together, and then move the smaller item to the left side of the array and the larger item to the right side of the array. This happens all the way back up the stack until you have a merged and sorted array. So for instance, if the left array was 3, 7 and the right array was 2, 8, we would compare the first item in each array, in this case 3 and 2. 2 is smaller than 3, so our merged array will start with 2, leaving us with 3, 7 in the left array and 8 in the right array. We compare again, this time it's going to be between 3 and 8, and 3 is smaller than 8, so it's going to get pushed into the merged array and popped out of the left array, so we're left with 7 and 8, and because that's already sorted, we just push those into the merged array. This will leave us with an array of 2, 3, 7, and 8. So let's write it. So let's start by defining our merge function. This will take in a left and a right array, and it will merge them together so long as there are values in each array. We're going to define a new array called merged array, and this is where our merged items are going to be held. So now we're going to check to see if the left and the right array both have items in it, and while they both have items, we will continue to iterate over these arrays and merge the first item in each array. So we're going to say while the length of the left array is greater than 0 and the length of the right array is also greater than 0. Now we can actually compare the first items in both arrays. Now we're going to say if left array at index 0 is less than right array at index 0, we are going to say merged array dot append, because we're going to add the lesser value into the merged array first. So left array dot pop and index 0. So what we're doing is we're actually removing the first item in the left array because the left array's first item is smaller than the right array's first item. So the reason we're doing a pop at index 0 here is because we want to actually remove that value from the left array because that value is smaller than the first index in the right array. And this will allow us to constantly go through this while loop without actually having to say, hey, we already looked at this number. We can actually just continue to compare the first item in each array. So we're also going to do it again. Else I'm going to say right array dot pop index 0. Now with this method, we're only comparing whether or not it's bigger or smaller. So in this while loop, if the left array runs out of values or the right array runs out of values first, we're going to exit the while loop and we're going to say return. We're going to return the merged array plus the items in the left array and the items in the right array. So next we're going to actually define our MergeSort function. I'm going to say define MergeSort, and this is where we're going to actually pass our unsorted array. So we're going to say unsorted array equals. So we're going to check our base cases here. We're going to say if the length of unsorted array is less than or equal to 1, we're just going to return the unsorted array because there's nothing for us to do. It's already sorted. So if we pass that check, the next thing we want to do is we want to find the midpoint of the array so we can actually split it into 2. So we're going to say midpoint is equal to the length of the unsorted array divided by 2. Now we're using the double slashes because we want to get an integer value rather than a float value because we can't pass a float value into an array to get a value. So now that we have our midpoint, we're going to actually create two different arrays. We're going to create a left array and a right array. So we're going to say the left array is equal to the unsorted array, and we're going to pick out all of the items on the left side of the array up to the midpoint. Then we're gonna say create a right array, and that's gonna be unsorted array. And we're gonna get all the items from the midpoint all the way to the end of the array. So now we split our array in two. So here's where the recursion comes into play. We're going to say return merge, which is what we defined up here. So then for the left array, we're going to say left array equals, and we're going to call our MergeSort function that we are currently in, and that's why it's recursive. So we're going to say MergeSort on the left array, and then the right array, we're going to again MergeSort on the right array. So we don't actually care whether or not the values in the left array are all smaller than the values in the right array for this first instance, because once all these values are merged in the left array and merged in the right array, we do one last merge, and that's actually going to compare all the sorted values within the left array and the right array, leaving us with a merged array. So let's create a random array here. We're going to say unsorted array equals, and let's go with 12, 15, 10, 8, 5, 7, 9. Alright, let's try this. We're going to say print MergeSort unsorted array. I'm just going to go over my code again and make sure I have no typos. Alright, so I think I'm good. So we're going to test this out. We're going to say Python. I named mine MergeSort. So far our array is 12, 15, 10, 8, 5, 7, and 9. These are all distinct and completely randomized. So we're going to press enter and see if we can merge it. And there we have it. We have done the MergeSort algorithm on our array. We have 5, 7, 8, 9, 10, 12, and 15. Alright, so that was the MergeSort array. I hope you enjoyed this video. Please hit the like button and don't forget to subscribe, and I'll see you in the next one.